All right, last one, we're going to talk about kind of taking a picture and being able to find the information from the graph. Okay, so determine the period, frequency, midline, amplitude, and then the function. So now that we know what these things do, there's two options, okay? We're going to have, at the end of the day, a function that's for a sine and a cosine, okay? And we're going to go with the easier of the two to create, all right? Let's see, looking at this one, it kind of looks like it cuts in half here. Now, how do I know that? Because, well, I drew a line to see if it would be equal on both sides. It's a visual game, okay? If you draw a line and you decide that that's not right, then go back and draw a different line. But if I look at -1 here, I've got the same amount going up as I do going down. So here looks like goes up about 3, and here goes down about 3. Now that answers both two questions. What is the midline? Y equals -1. And what is the amplitude? 3. Cool, looking good. So that's the way you can determine the midline and the amplitude. The period, you want to look for where it's one complete curve. Okay, now with either cosine or sine, you should have the same period conversation. So if I look at the sine version, one bump up, one heartbeat up, one heartbeat down, right? That would be a complete sine. Up and down and back to 0. Looks like that happens in 1 pi amount of time. Now, I could also look at cosine. Here, kind of harder to do that though, right? Because it'd be from here to here. I do kind of call that pi over 4 to what? 5 pi over 4? But again, pi over 4 to 5 pi over 4 is the same thing as, as pi. So either way, we end up with a pi frequency. A pi period, pardon me. Which means the frequency would be 1 over pi. Okay, now that's all fine and dandy. So now we have to come up with a function. Some parts are easy, some parts are a little harder. Let's just pretend this is a sine function, right? Let's pretend there's no horizontal shift here. We're going to do that one in a second. But there's no horizontal shift and it's a sine function. Y is equal to sine x. Okay, so I put in the frame here. But there was a shift of 3, right? It's not a 1 up and down, it's a 3 up and down. And there was something on the end here, a -1. The other thing that's kind of a little harder to figure out how to add it in is that the period is twice as fast. Where it normally takes 2 pi for a sine to complete, this one's only taking 1 pi. And so what happened is the period has been cut in half. So what do I need to add? A 1/2 or an x over 2. Okay, so you have to do a little bit more thinking with the period. It's not just plug in the number, but not super bad. This would be our sine function. Now we could also do a cosine function. Usually they'll tell you which one you wanted to do, but we wanted to make sure you could do both. So cosine x, we'd have all the same pieces. Still be 3, still be 1/2, and still be -1, but this time the cosine has shifted. We decided about pi over 4. So a right shift of pi over 4. So either one of these functions would really be acceptable. Any computer program will tell you which one they want. All right, let's do it again. So let's see, midline, I'm thinking probably 0. Amplitude, 1. Ooh, period's a little harder. This one's going super fast. So let me see if I can figure out, here's sine. That's kind of awkward to look at. Like where does that stop? Another thing you can do, instead of trying to figure out the period, try figuring out the frequency, right? We're talking about how many cycles per 2 pi. Here's 2 pi. Whoops, that's an eraser. How many cycles? 1, 2, 3, 4, 5, 6, 7. And so we have a frequency of 7 per 2 pi. No, we don't have to have 1 over, just because all of our other ones have had 1 over 6 pi, 1 over 4 pi, 1 over 6 pi, 1 over 2 pi, whatever it is, right? It doesn't mean we have to have 1 over. The frequency here is 7 per 2 pi, which means if you flip that, the period is going to be 2 pi over 7. Cool. So that's an easy way to use frequency to figure out your period instead of using period to figure out your frequency. All right, function time. We've got sine of x. This one, nice classic sine of x, right? We were definitely counting those sine functions. Sine of x, we've got no midline, one amplitude, but the period is now 2 pi over 7. So we need to take this, make it 7 times as fast. 7 times as fast means times by 7. So this would be y equals sine 7x. Or y equals cosine 7x, but that x has to be shifted over. This is where it gets a little tricky to find a cosine. Let's see. We get 7 per 2 pi still, because there's 2 pi. So what's 7 divided by 2? 7 divided by 2 is 3.5. So, that didn't know me. So it'd be 7 over 2. Let's see if we can find one that's actually kind of hitting it. Okay, check this one out. See how that one actually hits it at 3 pi over 2? I'm going to make my life easy. It's periodic motion. I don't need to use the first one. If I say this is minus 3 pi over 2, well, then all the waves just get pushed over, right? I don't have to figure out the first one. As long as it's still that wave motion, it's going to hit right there at 3 pi over 2. I'm going to use that as my shift. One of the benefits to having periodic motion. So cosine 7 shifted right, negative 3 pi over 2. All right. Cool. Let's do it without a graph this time. Let's see if we can determine period, frequency, midline, and amplitude just being given a function. Okay. Given a function. Midline to me is always the fastest. It's just that thing on the end there, the transformation that it went down for. The amplitude equally is nice. It's an amplitude of 2 instead of amplitude of 1. The period here might take a little thinking. I've got the 2 pi period being divided out by 1/3, right? Being divided out by 1/3. It's 3 times as slow, aka 6 pi. And therefore the frequency is going to be 1 over 6 pi. We could have done the same thing, like made the frequency 1/3 over 2 pi and simplified. We would have gotten that and then flipped it back. Either way, that's what you get for all 3 of these. So not super bad. All right, the last 2 are just kind of concept problems. This first one, what do you see? The difference between the function 3 sine of x minus 1 and the function 3 sine 2 of x minus 1. Well, we've been talking about what the period does. This one just makes it go twice as fast. 2 times as fast. Now, your teacher may choose to explore this one a little more depending on what time you have, but this video is already getting a little lengthy anyways, so I'm going to go ahead and just call it there. The very last thing from this chapter that I want to do is talk about a word problem. A company is selling snowboards. They see a trend throughout the year that in the summer months they're losing money, but in the winter months they are making money. Based on their data below, what kind of function could this trend be? Plot the data on the graph with labels and identify the function that fits best. Include the amplitude, midline, and period. Okay, so those 3 words kind of shout out that it's either going to be a cosine or a sine function, right? Also because we're in the section. But this idea that snowboards, right? They don't really sell in the summertime. Nobody really buys snowboards as a summer gift. But in the winter months, oh, bank, snowboards are awesome, right? So let's just plot this data. Let's just start with that. Let's get a visual representation. It looks like top 54,000, 75,000, bottom 53,000. Okay, so let's maybe do, here's the middle. Let's go up by like 10,000s. And then we got our 12 months, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 months. And then we'll do 10,000, 10K, 20K, 30K, 40K, 50K, 60K, 70K, 80K, okay, negative 10K, negative 20K, negative 30K. By the way, in case you haven't noticed, K means 1,000. So I'm just not writing the thousands down. 50K. And then I don't think we need anything past negative 50K. Oh, we need 60. Just kidding. All right, let's go ahead and plot now. So January, we hit 54. So probably like around there. Okay. You could have chosen to put January on the y-axis. That's fine. I mean, it's the beginning of the year. Second, 45-ish in February. So like there. Nope. There we are. 35 in March. So we're down another 10. And then, ooh, a little drop in April to 12. Like right about there. June, not so much. Not June. Sorry. May. May is like just sneaks right above. Not even 1,000. June. Whoa, negative 42. Talk about your nosedive, huh? Negative 42. Right about there. July, negative 54, 53. Oops. Sorry, my July is one over. Okay. August, negative 30. Okay, going back up a little bit. Negative 32-ish, right? 32? 30. 30.2. Negative 10 in August. Okay, not losing as much money there. And then we're back to at least making some money in October. November 15. And then we see in December it skyrockets up to like 75. All right. Now, as with the real world, this is not going to be a perfect sine or cosine function, but which one do you think it more relates to? I think it looks a little cosine-ish. And as the year goes on, what's going to happen? It's going to go back down again and back up again as it comes back to winter, and then go down as it comes back to summer. And again, we see that periodic motion. And so this business can start to use that to plan their situation. Okay, and I think it's more representative of a cosine. You could say a sine with a shift. You'd be right. Okay, that's really up to you. More importantly, what's the amplitude here? I would say the amplitude for these guys would be about 50,000. It's going 50,000 in both directions. What's the midline? 0, unfortunately. That is their midline. You would hope that they would make money at all times, but no, their midline is 0. And what is their period? The period would be probably every 12 months. All right. Beautiful example, beautiful non-physics example about where you see sine and cosine functions, but really anything that's periodic, anything that goes up and down and up and down and up and down, usually ends up being a sine or a cosine function. All right, that is it. That is all that is 6 point anything. That is the Unit 6 trigonometry chapter. Good luck on your unit test, and I will see you again in inverses.